everyone, this is Abdul from Pythonist. In this video, we are going to explore multiprocessing in Python. We will see that what it is, why it is important, and how we can implement multiprocessing in Python. So let's get started. Consider a computer with a single processor. If it is assigned multiple tasks at the same time, it will have to interrupt each task and switch briefly to another one to keep all of the processes going. The example of a chef working in a kitchen alone aligned very well with this concept. Another name of this concept is parallel processing. Parallel processing is getting more attention nowadays. If you still don't know about it, don't worry, we are going to cover this topic in this video. As CPU manufacturers start adding more and more cores to their processors, creating parallel code is a great way to improve the performance of your programs. Python introduced a multiprocessing module to let us write parallel code. To understand the main motivation of this module, we have to understand at least 4 most important classes of this module. These classes are the following. The very first one is the process class. The second one is the lock class. And the third one is the queue class. And the last and fourth one is the pool class. There are various other classes are also available in this module, but if you have good understanding of these 4 classes, you can write much efficient code supported by multiprocessing. So let's explore these classes one by one. But before describing about those, let's start the story with a very simple thing. To make a parallel program useful, we must have to know that how many CPU cores are available on our system. And this multiprocessing module provides us a very simple way to get that. We just have to import this module as import multiprocessing as MP, and then we need to call the CPU_count method as mp.cpu_count, and it will print out the number of CPU cores available on your system. That's great. So let's start with the very first class, which is the process class. The process is the forked copy of the current process. This creates a new process identifier, and the task runs as an independent child process in the operating system. There are 2 important functions belong to this class, start and the join function. So let me explain the complete workflow of a process. The very first step is we have to create a process object. But at this stage, nothing will happen until we tell it to start processing using its start function. At this stage, the process will execute and return its output. After that, the process will remain idle and wouldn't terminate until we call its join function. Keep in mind that if you create many processes and don't terminate them, you may face the shortage of resources. So let's write a very simple program to understand this class. So I will define a function named as myFunc and print a simple statement inside this function. Then in our main function, I will create an instance of process called proc, and we need to pass our function as a target for this process. So it will execute this function, then we need to call the start function to start the process, and finally I will call the join function to terminate this process. If we run this program, you can see our statement has been printed. That's a very simple use of this process class. Let's expand this program and utilize other features of this class. Now I will define a function named lang_func, which takes a parameter named lang. Then inside this function, I will print a very simple statement which prints out our parameter. Then inside our main function, I will define 2 different lists. The first one with a bunch of names of different programming languages called langs, and the second one will be an empty list named processes. After that, I will create a process for each language and call the start function with the help of a for loop. So I will say for L in length, then we will start a process as proc equal to process and pass our function as the target for this process. And we also need to pass the arguments by using the args keyword argument in the form of a tuple. Then I will append it to the processes list by calling the append method. And finally, call the start function. Then after that, I will create another for loop to stop these processes as for p in processes. Then inside this loop, we have to call p.join function. So it will stop these processes. If we run this program, you can see the output here. That's how we can utilize the process class to create multiprocessing in our programs. The second class is the log class. The concept of log is quite simple. In real-world scenarios, there's always multiple processes need to be implemented in our code. So in this case, we have to manage the multiple processes and need to bound the code to process. And to get the proper result, we must need to log that chunk of code. So the task of log class is mainly two. One is to claim log and other is to release the log. To enable the log for a code, we need to call acquire function, and to release the log, we need to use the release function. That's it. I think that's enough for this video. So we will discuss the remaining two classes in our next video. Keep watching, stay connected, and if you like the content of this video, be sure to subscribe to my channel and hit the bell icon so you will get a notification for any fantastic video in the future. Thanks for watching.